Module 4, Lesson 32, Multi-Step Problems in the Real World. We are going to continue to focus on these last two learning targets. I can write and solve equations and inequalities involving real-world problems. In this lesson, we'll be very focused on the equation portion. Inequalities are coming. I can analyze dependent and independent variables using graphs and tables and relate them to an equation. We are going to be doing both graphs and tables in this lesson. I can statements. I can identify the independent and dependent variable. I can write an equation to represent the situation. I can create a table with the independent variable in the first column and dependent variable in the second column. I can complete a table by substituting values for the independent variable and finding the resulting value of the dependent variable. And I can make a graph for the equation by plotting the points in the table. We did these first four items in the last lesson, so we will review those and we will add the graphing piece in this lesson. Chen is buying beverages for a party that come in packs of 8. Let P be the number of packages Chen buys and T be the total number of beverages. The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. So which of these is the independent and which of these is the dependent variable? Hopefully you've started to notice that in our equations, the independent variable is here with other stuff, and the dependent variable gets to be all by itself. So P right here is our independent variable and T is our dependent variable. And P is the number of packages, so the total number of beverages depends on how many packages Chen buys. So we've identified our dependent and independent variables, and now we're going to create a table, and we are supposed to have number of packages that is less than 6. Alright, independent variable is the number of packages, dependent variable is the total number of beverages. And you can see I've got my table set up here. I've got my 2 columns with my headings. Notice that I have included my variables and equations as part of my headings. Much easier to do when I've typed it up instead of having to handwrite it on the screen. And I am supposed to have packages less than 6. So that's 1, 2, 3, 4, and 5. And the total number of beverages is the number of packages multiplied by 8. So 8, 16, 24, 32, and 40. So the values in column 1 are the number of packages, and it says to do whole numbers less than 6, so I did. And then I completed the table by substituting the number of packages. Oh, of course I used a 0 to start with. Now the new step, this was all review, we did this yesterday. Our new step is let's make a graph for this table. To make a graph, we have to determine which variable is going to go on the horizontal axis, or the x-axis, and which is going to go on the vertical axis, which is the y-axis. Usually, normally, generally, the independent variable is measured along the x-axis. We would have our independent variable. And our dependent variable would go on our y-axis, our vertical axis. So what would we put on our x-axis, this horizontal axis? We would be putting the number of packages. What would we put on the vertical axis, our y-axis? That would be our dependent variable, or the total number of beverages. So pause and use a piece of graph paper. If you don't have graph paper, use a piece of line paper and just make something that looks reasonable, neat and tidy, and create a graph. Make sure that you have your X and Y axis. Make sure you label for the X and Y axis. Make sure you have a scale for the X and Y axis. Make sure that you have your title, and make sure that you have plotted the points using the table. Now I'm going to walk you through each one of these, so follow along on your paper. So here is my grid paper, and you can see that I have my Y-axis here, and I have my X-axis here. And you can see that I have labeled a title for my X-axis, the number of packages. You can see that I have labeled or put a title for my Y-axis, the total number of beverages. You can see that my entire graph has a title, Beverages for the Party. So I have taken care of several of the things off the list here. I have an X and Y axis. I have labeled the X and Y axis. I have not yet done a scale. I need to do that. But I have done a title, and I have not yet done the points. So looking at my graph here, I need to ask myself, what is the scale? Now the scale is what I am going to be counting by. As I look at my table, I can say, well, I'm counting by ones for the number of packages. I start at 0 packages, and then I have 1 package, 2 packages, 3 packages, 4 packages, and 5 packages. As I look at my beverages, I can see that I'm counting by 8s there. Once again, I have 0 beverages, but then I'm counting by 8, 16, 24, 32, and 40. Now this problem is very nice because we have a very uniform set of data. Nice, even intervals. As you get into more advanced problems, it's not going to play so nice, but for today, it's great. It's fine. We appreciate a simple problem. So I have my scale. I decided to count by 1s here. I counted by 8s here. And of course, you wouldn't actually draw those lines that I just drew over the top of everything. The last thing we need to do is add our points. And if you go back to, or remember what we did with ratios, our independent variable is our x coordinate, so 0, and our dependent variable is our y coordinate, so I will plot a point at 0, 0. I have an x coordinate and a y coordinate, 1, 8, 2, 16, 3, 24, 4, 32, 5, and 40. Now an important question to ask is, should I connect the lines as I look at this graph? Connecting the line actually means something. I know that we get really excited and we want to connect the line because it looks like a cool little dot-to-dot puzzle or something like that. But when we connect the line, it means that we have a continuous set. It means that I could potentially have half a package and have 4 beverages. Now, can you go into the store and say, I don't want the full package, can I just buy the half package? Would you just open that up and take 4 of them out for me? And the answer is no, you couldn't do that. When you go to the store to buy packages of soda, they come in full packages. So we are not going to connect the line on this because I cannot use the information in between here. I can't do anything with these spaces. I can't buy half packages or quarter packages. That's not how they are sold. So I'm not going to connect the dots and draw a line there. All right. And I've already done this, and I've done this. All right, let's look at example 2. Use the graph to determine which variable is the independent variable and which is the dependent variable. Then state the relationship between the quantities represented by the variables. So we are going to try to find the relationship between the two parts here. So I've got number of hours, I have number of miles, and I have a road trip. Which of these is the independent variable? Well, we already said that we normally put the independent variable on the x-axis. So the number of hours should be our independent variable. And our number of miles should be our dependent variable. Now the relationship here. So I have to do a little bit of analysis. What is the connection between 1 hour and 50 miles? What is the connection between 2 hours and 100 miles? Well, what we're seeing here is if I travel 1 hour, I've traveled 50 miles, and 2 hours is 100 miles. So I'm finding that I am traveling 50 miles every hour. It's showing me a ratio relationship. It is showing me that the number of miles is equal to 50 times the number of hours. So I can look at this graph and I can see this equation as I look at this. Now this is an interesting conversation to have. We just had a discussion about whether or not we should connect dots. On this particular graph, I would say that we should connect the dots because I can travel for half an hour and have gone 25 miles. So on this one, I would connect the dots. But more importantly is that I can look and say there is a relationship between miles and hours. The miles will depend upon the hours, and I multiply the hours times 50. All right, let's practice. We've got 3 or 4 exercises here to give this a try with. Each week, Quentin earns $30. If he saves this money, create a graph that shows the total amount of money Quentin has saved from week 1 through week 8. Write an equation that represents the relationship between the number of weeks that Quentin has saved his money, W, and the total amount of money in dollars he has saved, S. Then name the independent and dependent variables. Write a sentence that shows this relationship. So we have a lot of things we're going to do here. We're going to put a whole bunch of stuff together. So first thing it says, let's create a graph. Well, I need to identify the independent variable. Well, he's earning $30 each week. So if he's worked 2 weeks, that's going to change the amount of money. So I hear that the number of weeks is an independent variable, and that we are supposed to use a W for that. And that means the amount of money that he has saved, W, let's see, the amount of money is S. So dollars, writing sideways is not so easy, dollars, I want dollars, dollars saved. And that's supposed to be S. Okay. Money Quentin has saved. Okay, so I've labeled my x-axis, I've labeled my y-axis, I've labeled my graph. I'm going to start at 0. And I've got 1 week, 2 weeks, 3 weeks, 4 weeks, 5 weeks, 6 weeks, 7 weeks, and 8 weeks. And it's okay if I ran out of room. I can just extend my graph. It's okay. It doesn't have to be super perfect. We are human beings and we can understand things. All right, now he's earning $30 each week. So 1 week is $30. And 2 weeks is $60. 3 weeks is $90. 4 is $120. 5 is $150. 6 is $180. 7 is $210. It's going to get super squishy here. Hopefully you had more room on your paper than I have on my board here. Okay. And I'm not going to connect these dots because I feel like what Quentin's going to do is earn his money and then save it. He's not going to be doing a little bit every second all week long or every day all week long. All right, so I've got a graph. Shows the total amount of money he saved from week 1 through week 8. I need an equation. Well, I'm going to move over to my table to help me with the equation here. I have the number of weeks, and his total amount saved is going to be 30 times the number of weeks. So there's my equation. So graph is done. I have an equation. I have named the independent and dependent variables. I need to complete my table here. And the last thing that I need to do is I need to write a sentence that shows the relationship. And I've got a small space problem here. So I'm going to erase some graph stuff and write my sentence out. The amount of money Quentin has saved is 30 times the number of weeks he has been saving. And I could say 30 times greater the number of weeks he has been saving. But the big thing here is I've written a sentence that describes that equation. All right, let's look at exercise 2. Zoe is collecting books to donate. She started with 3 books and collects 2 more each week. She is using the equation the number of books is equal to 2 times the week plus 3, where B is the total number of books collected and W is the number of weeks she has been collecting books. Name the independent and dependent variables. Create a graph to represent how many books Zoe has collected when W is 5 or less. I'm going to start on the table this time because I know that I have the number of weeks is my independent variable. I just have to look at this equation here. And I know that the number of books is going to be equal to 2 times the weeks plus 3. Now the plus 3 comes from she started with 3 books. That's a constant. She had 3 books and then she started collecting the 2 more each week. So the 2 times the week is take each week, multiply it by 2, but remember to add the 3 that she had already collected. Okay. All right, and I'm supposed to do 5 or less. So 0, 1, 2, 3, 4, 5. Using the 0 becomes important as we start to put things on the graph. 0 helps us see what is happening when our independent variable is 0. So if the number of weeks is 0, the number of books is actually 3. And that kind of comes as a little bit of shock to people who are used to starting at 0, 0. But when our number of weeks is 0, she has collected 3 books. And when we have 1 week, we have 5 books. And when we have 2 weeks, 2 times 2 is 4 plus 3 is 7. And we got 9. And we got 12. And we've got 14. All right. Let's see, name the independent dependent variables, create a graph to represent. Okay, so I've got the number of weeks. I've got the total books. which is B, and the weeks is W, and I've got books collected by Zoe, and I've got 0 weeks, 1 week, 2 weeks, 3 weeks, 4 weeks, 5 weeks. All right. Now, doing the y-axis here, the scale that I'm going to put on here, I'm not going to be able to do something nice like I did on the last one and just go straight up the side. I'm going to have to do some in-between spaces. I'm going to count by twos. 2, 4, 6, 8, 10, 12, and 14. So to start with, no weeks, she has collected 3 books, and 1 week we are at 5, and 2 weeks we are at 7, and 3 weeks we are at 9, and 4 weeks we are at 12. Is that right? 4 times 2, nope, we're at 11. Boy, it's a good thing I'm checking my work here. 13. All right. Whew. Oh. All right, so here is 11, and at 5 weeks I am at 13. Boy, if we were in class, I'd say, why didn't somebody raise their hand and let me know I messed that up? So on my scale here, I couldn't just do 3, 5, 7, 9, 11, and 13, because that would have left me a gap of 0 to 3 at the bottom. One of the rules of a scale is that your scale has to be uniform. You have to count by the same amount every time. So by counting by twos, I was able to start at the 3, and then I was able to do the odd numbers halfway in between. So remember, one of the rules of scale is you can't go something like this, 0, 3, 5, because this difference is 3 and this difference is 2. That's not okay when you're making a graph. Your intervals must be the same. So I have an interval of 2, 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 and an interval of 2. That is okay. All right, let's look at exercise 3. So Eliana plans to visit the fair. She must pay $5 to enter the fairgrounds and an additional $3 per ride. Write an equation to show the relationship between R, the number of rides, and T, the total cost in dollars. State which variable is dependent and which is independent, then create a graph that models the equation. Well, I heard that there is a $5 always, so that's a flat fee. So I know that when I look at her total cost in dollars that there has to be a plus 5 because that's the flat fee. Now it says that it is $3 per ride. So her total cost is going to depend upon the number of rides. My independent variable is how many rides does she go on. My dependent variable is how much is this trip to the fair going to cost. And it says it's $3 per ride, so I know that I take the rides and multiply it times 3. So I have my independent variable, I have my dependent variable, I have my equation, I have included my $5 flat fee, and it says I am creating a graph that models the equation. Well, I'm going to start with 0 rides, and if she doesn't ride any rides, if all she does is just go to the fair to look at the exhibits, she's going to pay $5. If she rides 1 ride, it'll be 3 plus 5, which gives us 8. If she rides 2 rides, 2 times 3 is 6, plus 5 is 11. If she rides 3 rides, 3 times 3 is 9, plus 5 is 14. If she rides 4 rides, 3 times 4 is 12, plus 5 is 17. All right, so making a graph here, I've got the rides, number of rides, which is expressed as the variable R. I have the total cost, and that's going to be in dollars, and I've got the cost to go to the fair. And I've got if she rides 0 rides, 1 ride, 2 rides, 3 rides, 4 rides, 5 rides. And now I have to figure out what I'm going to do on the y-axis here. Once again, I can't just go 5, 8, 11, and 14 because I have to have that nice even interval. So I've got to pick something that's going to be reasonable for me to work with. I'm going to count by 2s because I see I've got some even numbers and I've got some odd numbers, so I want to be able to easily find them. 2, 4, 6, 8, 10, 12, 14. I could count by 3s, but then I have to find 1 and 2 inside. If I just count by 2s, then all I need to do is find halfway to be the odd numbers. All right, so if she rides no rides, it costs $5. And if she rides 1 ride, that's $8. And if she rides 2 rides, that's $11. And if she rides 3 rides, that's $14. And of course I've got 4 rides, which is clear up here at like $17 off my graph there. I'm not going to connect them. I'm not going to connect them because they're not going to let me ride 1.5 rides. So it's very separate data points. So imagine you are helping a friend with his math work, and here is the problem he was solving. Henry is taking a taxi cab home. The cab company charges an initial fee of $5. Okay, I heard that flat fee part there. No matter what you do, it's going to cost you $5, plus $2 for each original mile. Henry uses the equation T equals 2 times M plus 5 to calculate the cost of the ride, where T is the total cost and M is the number of miles. So T is our total cost, M is how many miles we traveled, it's $2 for each of the miles, he's got the $5 flat fee. Great. Your friend states that T is the dependent variable and M is the independent variable. Then the friend starts to sketch or draw a graph. What would you tell your friend when looking over their work? So we're going to visit with our friend and say, hey, I think you did these things awesome, but maybe there's something here that's not quite right. So I've already taken a look at this part here and decided I really like his equation. He did a great job. Henry, you did a really nice job on your equation. Let's look at your graph. Now, as I recall on a graph, your independent variable is supposed to be on the x-axis. So the independent variable is the number of miles. Henry, if I were you, to kind of do what most everybody else does, I would reverse the number of miles and the cost of the ride. I would bring the miles over here and I would bring the cost of the ride over here, so that your independent variable is on your x-axis and your dependent variable is on the y-axis. Okay, I can statements. Hopefully you are feeling pretty good now. We have practiced for 2 lessons identifying the independent and dependent variable. For 2 lessons we have practiced writing an equation to represent the situation. We have worked for 2 lessons on creating a table with the independent variable in the first column and the dependent variable in the second column. We have substituted values for the independent variable and finding the resulting value of the dependent variable. And then today we extended ourselves and connected it to making a graph. So we have written and solved equations involving real-world problems. We have analyzed dependent and independent variables. We have used graphs and tables, and we have connected them to an equation. So that concludes Module 4, Lesson 32. If you have questions, be sure to reach out to your teacher. Make sure that you have completed your problem set and your exit ticket.